In this video you will learn what the commutative property of addition is, a simple trick for remembering it, easy to understand examples of why it works, and finally how you can use it to your benefit. The commutative property of addition can be written as a plus b equals b plus a, where a can be any number and b can be any number. For example, we can replace a with, let's say, 2, and we can replace b with, let's say, 3. So the letters a and b are just placeholders for any value. So why is it called commutative? Well, if we take two numbers and put on each side of an equal sign, in order to show the commutative property, we flip around the numbers on one side. For example, on the right hand, we move the positions of 2 and 3. So the numbers, they move. In other words, they commute. And this is also a good trick for remembering this property. For example, you may commute to school or commute to work, and the numbers, they commute as well. So why does this work? Let's look at an intuitive way of showing how this works. If we take the first number, which is 2, and we add 2 blue boxes, and then we take the 3 and add 3 green boxes, and for the other side we have 3, so we add 3 green boxes, and for the 2 we add 2 blue boxes. Now, if you look at these two shapes, it's clear that they are the same size. In fact, if we put them next to each other, it's even more clear. So this expression 2 plus 3 equals 3 plus 2 is correct. We can see it. It's just like the one side is flipped around. It's like you flipped one of the figures around. But what if you have more than 2 numbers on each side? Let's try it. Here we have 1, so we add 1 box, and then 5, so we add 5 boxes, and then a 3, so we add 3 boxes, and then an 8, so we add 8 boxes. Okay, for the other side we have a 5, so we add 5 boxes, and we have an 8, so we add 8 boxes, and then 3, and then last 1 box. And as you can see, these 2 rows of boxes are the same size, and if you count the boxes you will see that they contain the same number. So the commutative property of addition works with more than 2 numbers. In fact, it works with any number of numbers. The number of numbers doesn't matter, it will still work. So why is the commutative property of addition useful to know? Let's look at one way we can use this. Here we have a collection of numbers to add up, and it's not that easy to do it. You could do it if you wanted to, but there is some work involved in doing this. So one easier way to add these numbers would be to take out pairs that together are 10. For example, you can take a 6, and then we need 4, and we get 10, and then we can take 7, and we would need 3 to get another 10, and then we can take the 8, and of course we need 2, and now we have another 10, and well, there's just the 1 left, so let's add that. And as you can see, now it's very easy to add this. 3 tenths is 30, and then add 1, so you have 31. So the commutative property of addition can be useful for things like that when you want to make it easier to calculate something. However, there is one thing you need to watch out for. You can only move numbers that are not involved in other operations. For example, if you have 1 plus 2 plus 3 times 4, then the 3, you can't just move that. since it's involved in multiplication. So first you would have to either calculate 3 times 4, so you get 12, and now you can move the 12, or you could just move 3 times 4 as one unit, like this. You have 2 plus 3 times 4 plus 1. But when you calculate this, you would need to calculate 3 times 4 before you add the numbers together. This is because of the order of operations that you may be familiar with that says that you need to do multiplication before addition. So the commutative property of addition in conclusion can be written as a plus b equals b plus a. Is called commutative because the numbers can commute. In other words, they can be moved without changing the sum. And a key takeaway is that whenever you run into problems involving addition, you can move around the numbers being added as long as they are not involved in other operations. If you found this video useful, then please like and subscribe, and thank you for watching.